Hello, several of you asked for help on the homework, so I'm going to go through all the problems. 5 and 6 seem to be the most commonly asked question, but maybe some of you out there need some help on the other ones too, so I thought I'd go ahead and go over all of them, and then maybe we could try out some additional problems here. So when we're looking at this, we want to see the instruction set to identify the center, the vertices, the foci. I think it's also helpful to go ahead and just identify your A, B, and C when you go to try to graph it. So all those things we're going to find out and do. So the first thing I want to do is just kind of write it out in general form and identify the center. Notice our y squared is first here. So this is like saying y minus k squared over a squared minus x minus h squared over b squared equals 1. So the a squared term, remember it's always first with hyperbolas, is underneath the y. So I know it's going to be a hyperbola that has, it's going to be stretched out vertically like this, or has the vertical transverse axis to it. But my center is at h comma k, right? So it's going to be the opposites of these right here. So they're both -1. And so the center is going to be at 1, 1. So let's put that mark down. Center is at 1, 1. And after that, I want to find out what my A and my B value are. So center is at 1, 1. And A squared equals 9. So A must equal 3. And B squared, it's like having a 1 right there. B squared equals 1. So the square root of that is 1 as well. So your A and your B are both 1. Now, I like to do a little something different than some people. I like to draw a box with those dimensions from the center. So I know that A is on the transverse axis here, and I'm going to go up 3 from the center. 1, 2, 3, and put a dot. I'm going to go down 3 and put a dot. B's length is 1. I'm going to go to the right and put a dot here, and to the left 1, put a dot. That's your B value. And I want you to form like a rectangle right here. And what this rectangle does is it allows me to draw my asymptotes for it. So my asymptotes go along the diagonals. Oops, not like that. Let me make this a little bit of a thinner line for an asymptote. So it goes through just like this. So just draw a line connecting the corners. And you can almost just draw your hyperbola here. You know, they go towards the asymptotes, hit your vertice, and then go back up. But we're going to find the other points that they want to find as well, the foci, the vertices. In fact, right here are my vertices, here and here. So it's just a distance A away from the center. So our vertices, you have 2 of them. You have 1. They both have the same x value. That's at 1. And the y value is 4 on the top one and -2 on the other. So there's your vertices. The foci are a distance c away. And so the nice thing about hyperbola is we can use the equation a squared plus b squared equals c squared. That gives us what c's value is. So we've got 9 plus 1 equals c squared, where c is equal to √10. So if you go away from the center, up √10 and down √10, you'll hit your foci. So let's see our foci. And I don't mind if you just leave it like this. We know our x value stays the same. And we're just adding to that center y value, which is 1. So we're going to say 1 plus √10. And that's going from here up √10, which is about like, I want to say it's 3.16, 3.2. So we go up 1, 2, 3, and just a little bit. There's one foci. And then we're going to go down 3, and then just a little bit. There's the other. And so it's also going to be 1 minus √10 right here. So there's your foci, your vertices, your center. We can sketch our ellipse now, and I'm going to sketch it in purple. So it's going to come through this one vertice and towards the asymptote, and then through the other and towards the asymptote. Same thing down here. All right, and there's your solution to number 1. Oh, wait, it did ask for the asymptotes, so not just the lines drawn here, but the actual equations. So I want to write out the equations of these two lines, and it's a fairly simple process if you use point slope formula. So slope formula, remember, is y minus y1 is equal to the slope times x minus x1, right? And x1, y1 stand for one specific point on the line. Well, I'm going to be writing out the equation of two lines here, and you could use several different points on those lines, like the corners of this box, but I like to use the center point because it makes life super easy because both equations almost look exactly the same. So if I use the center point as my x1, y1, the center is at 1, 1, I can say y minus 1 is equal to some slope x minus 1. That's for, we'll say, this one going uphill. And we'll go ahead and write the equation for the one going downhill as well. Since I'm going to use that same point, it's a mutual point between the two lines, it just is simple as copying it over. And so if you notice, all of this looks exactly like what the equation of the hyperbola was, except for I'm leaving off the squared part. I'm saying x minus 1 equals some slope times x minus 1. And that's why using that center point makes this super easy, because now all I need is the slope. Well, look at the slope of the line going uphill, connecting the corners of this box. If we start right here at the center, we go up 3 and over 1. Well, that's the same thing as a over b, right? Up 3 over 1, the slope is 3 on that. If we look at the slope of the one going downhill, we're going down 3 and over 1. So we go down 3 and over 1, that's negative 3. That's just the same thing as negative a over b. And there's the two equations of the asymptotes right here. So that's why I like drawing that box. I think it makes it super simple to see that as well. All right. So I went through that one kind of slowly. Let's, I mean, that was 7 minutes of video. I don't think you want to do that for all 6 problems, but we'll go through the next few a little bit faster since we've kind of got that base established with problem number 1. So on this next one here, we've got x squared over 25 minus y minus 3 squared over 4 equals 1. So this time we have the x coming first, so we know it's going to be something that looks like this. It's going to have our transverse axis going horizontal this time. Let's go ahead and identify our center. We are subtracting nothing from the x, so the center is going to be at 0, comma, opposite of negative 3 is positive 3. And let's go ahead and plot that point. So 0, up 3, there's your center. All right. Let's go ahead and see what our a and b is. This is a squared 25, so a must equal 5. B squared is 4, so b must equal 2. And let's plot those points. So the a is going to be going horizontal this time because we have that horizontal transverse axis. So we're going to go to the right 5 and to the left 5. B is 2, so we're going to go up 2 and down 2. And let's draw a box. And with that box, we can draw our asymptotes. So let's do that. I found the right tool. There. So right here is going to be 1. Right here's the other. And we just did it, so we just talked about it. Let's go ahead and write out the equations for the asymptotes. It's going to be y minus something equals some slope times x minus something. And I'm just going to write that out twice. Remember, we can use the same thing that's right here, that center point as it. So the center is at 0. The x value is 0 at the center. The y value is 3, so I can just put those in. And the slope here, remember, for this first one is going to be rise 2 and then run, what was it, 5. So it's going to be rise 2, run 5. There's your slope. For the slope of the other asymptote, you're going to be falling 2 and running 5. So fall 2 is negative 2 and run 5. There's the equations for the asymptotes. So we have our center and we have our asymptotes. Now let's find our vertices and our foci. So the vertices are going to be found right here at this dot. Remember, it's horizontal because we have a horizontal transverse axis. So right here is one vertice, right here is the other. So this is at -5 up 1, 2, 3. So vertices are at -5, 3, and then the other one is +5, 3. So there's the vertices. To find the foci, that's when we got to do our little bit of equation work here. We have a squared plus b squared equals c squared. We know a squared is 25, b squared is 4, so we end up with adding those two, we get 29 equals c squared, where c equals the root of 29. Now, I'm going to add that to the center, and because it's a horizontal transverse axis, I must go to the right c amount and to the left c amount. So I'm going to be adding and subtracting from the x value there. So if I add root 29 to 0, I get root 29. And if I subtract it from 0, I get negative root 29. And the y value stays the same at 3. This right here is going to be my foci. Don't forget your vertices are right here. That's everything they asked for. If you wanted to, you can say the square root of 29 has to be between 5 and 6, because square root of 25 is 5, and square root of 36 is 6. So you could go over 5 in just a little bit. These foci are very close to the vertices. And then when we go to sketch our graph, I'm going to sketch it in purple. It's going to be really close to the asymptote. That, and then go out towards the asymptote there. And same thing coming through like this. Go towards that asymptote like that. And there's your sketch of the graph. All right, the next one gets a little tricky for some students because you don't see any fractions there at all. So you're thinking that's not a hyperbola. But remember, it's not a circle because you don't have x minus h squared plus something y minus k squared. And it's not an ellipse. You don't have the plus symbol in the middle. This is a hyperbola as well. And what's in the denominator here is just 1. So that's what our a and our b is. Because y is listed first, we know this is going to be going in the vertical direction. So it's going to end up looking something like that. Because it's that, not so much as listed first. Well, it is in the proper form. Sometimes this negative comes out first and you got to switch them around. The negative should be in the middle and a plus right there. Let's go ahead and identify our center. The center is going to be at opposites here, so it's going to be at +4, -4. Remember, the x value right here pairs with the x value, and the y pairs with the y there. So at 4, -4, that's where we're going to be starting. And then our a squared term is 1, but when you take the square root, you get 1. B squared is also 1. Take the square root, you get 1. So our a and b are both 1. And so I'm going to make the box right here like this. So we're going to get a little square there for our box. We'll go ahead and draw our asymptotes. So it's going to come through like this. Let's write out the equations for those asymptotes. So I've got y minus something equals the slope times x minus something. This center point there is at, let's see, the y is, it's going to be -4, so it becomes +4. +4 becomes -4 there. Now the slope is rise 1, run 1, so you just get 1 for the slope. You can write out this again, and this time be -1 for your slope. That's the one going downhill. And I don't mind if you put plus or minus there if the slope's the same, which it should be for these two. So you might see in the answer key plus or -1. I'm okay if you do that, so you don't have to write out all this twice. You know, we got to write out a lot of stuff. So if you want to save some room, you can do plus or minus and then skip all of this down below. And that makes life a little bit easier. For the vertices, so here's my center. Here's the asymptotes. Let's just label all those in case some of you are just skipping through the video. You can kind of see which one's which. The vertices are going to be, because this thing is vertical, it's going to be here and here. So we're at 4, -3, and 4, -5. There's your vertices. The foci, we're going to use a squared plus b squared equals c squared. So this gives us 1 plus 1 equals c squared, or √2 equals c. And so I'm just going to add those to our y value there. So vertices are going to be the same x value as the center. So the center had an x value of 4. But then we're going to add √2 to the y value and subtract √2 from the y value. If I put a comma there, that should be a plus symbol. Here, let's erase -4 minus √2. So there's your vertices. And then lastly, we're going to sketch this. So sketching it, it's going to come through just like this. Let's try to make it as curved as we can. It's hard to do that on the computer. And there we are with number 3. So number 4, once again, start off by identifying, is this thing a vertical transverse axis or a horizontal one? It's going to be vertical because the y is first. So we know it's going to be, should be looking like this. I even kind of put that right there just to remind me as I'm doing my work, it's got to look like that in the end. So the center, we got nothing coming away from the y, and then 1 is coming away from the x. So that's where my center is. Remember, take the opposite value there, and if you see nothing there, it's 0. So the center is right there. And then, so let's go ahead and plot that, 1, 0. We know it's going to be going vertical. Our a squared is 4, so square root that, you get 2. Our b squared is 9, square root that, you get 3. So we're going to go up 2, put a dot, and then to the right 3, to the left 3. Draw our box. Draw our asymptotes. And then let's go ahead and write out the equation for the asymptotes. So the asymptotes are going to be at y minus something equals the slope times x minus something. And I'm going to copy that right there. It's going to have 0 and 1. And the slope is rise 2, run 3. But it can be plus or minus because we also have the negative version of that. So there's our 2 asymptotes. There's our center. Our vertices are already labeled. Now be careful. Remember, it looks like this right here. And so it's typical that we want to say the longer portion is A. And so this must be what it's looking like coming through here. But this is not our vertice. Our vertice is actually right here because it's vertical. It's just kind of like a really opened up hyperbola. So our vertice is at 1, 2. And the other one is at 1, -2. There's your vertices. Our foci, we get to do the fun Pythagorean theorem for the foci. So we say a squared plus b squared equals c squared. Our a squared and b squared are 4 and 9, so we get 13. And square root that thing, you'll get c. So that's our c value. I'm going to add that c value to my y value on the center. So we end up at 1, √13, because it's just 0 plus √13, and 1 minus √13. Or 1 comma, sorry, not 1 minus, but 1 comma, -√13. So there's my asymptotes, my vertices, my foci, my center, my a, b, and c value. Last thing to do here is to sketch the hyperbola. And so it's going to go and open up really wide. Kind of reminds me of like a bowl or something like that. And there's that one. So number 5, I got a lot of questions on how to do that. And I'm not surprised. I just wanted to see how much you could remember going back to when we did completing the square, because that's what we're really going to have to do here. So if that kind of leaves you with a, oh yeah, or that's how I should do this, maybe you want to pause it and try it before you watch me do it. Just kind of challenge yourself. Is completing the square a big enough hint? And even if you not sure you can do it, I would try to do it right now. Pause the video, try to do it with the hint of we're going to have to complete the square, because we need to make this thing look like the standard form of a hyperbola. All right. So I'm taking that you tried that out. I know some of you didn't. Pause it now and do it. All right. So anyway, let's try this. First thing I'm going to do is group my x's. So I've got negative 9x squared minus 18x. I'm going to group the y's. I get y squared plus 4y. Now this negative 14 doesn't have an x or a y with it. I'm going to temporarily right now just move it over to the right. So I'm going to add 14 to both sides of this equation, and I get the 14 over there. From there, I'm going to factor out. I'm just going to kind of like write this thing in parentheses. This is like a plus symbol right here. I'm just going to work the x's real fast, and I'm going to factor out a negative 9. And that gives me this right here. Over here, I'm not going to factor out anything. I'm just going to leave this as plus y squared plus 4y. Now, if you don't remember how to complete the square, go back and watch the video I have on completing the square. So, if this doesn't jog your memory any what I'm about to do. Okay? So to complete the square, remember, I'm going to take that middle term right here. I'm going to cut it in half. So 2 cut in half is 1, and I'm going to square it. So 2 and a half is 1, squared 1, you get 1. I'm going to complete the square. Well, actually, before we do that, let's go ahead and balance this equation out. What did I just add to the left side of the equation by writing 1 inside that parentheses? I didn't just add 1. I added negative 9, because this negative 9, if you distribute it in this parentheses, turns that 1 into a negative 9. So what I essentially did by writing inside this parentheses a positive 1 is I'm actually subtracting 9 from the whole left side of this equation right here. So I also need to subtract 9 from the right side of the equation. And I'll do that in a moment. Now, let's go ahead and complete the square over here with the y squared terms. I'm going to take this 4, cut it in half. And when you cut 4 in half, you get 2. And when you square 2, you get 4. Now, this thing doesn't have anything on the outside of it, parentheses wise. It's like having a 1 out there. So I really did just add 4 to the left side. So if I add 4 to the left side, I also have to add 4 to the right side. Okay? So I got 14 minus 9 plus 4 going on there. So that gives me what? Gives me 9. So the right side now equals 9. And the reason why I just did all that mess is because now I have perfect square trinomials in here, so I can factor that. So this is the same thing as square root of this first term, which is x, same symbol right there, and the square root of the last term, which is 1. So it's like saying x plus 1 squared. If you want to, you can test it. X squared is x squared, 1 squared is 1 squared. Multiply the 2 and double it, you get the middle term. It's a perfect square trinomial, or a binomial squared there. So that's what I have now. Same thing here. I can simplify this to the square root of the first term is y, same symbol in the middle, which is a plus. Square root of the last term is a 2. So it's like saying y plus 2 squared. And so this is getting closer and closer to looking like the equation of a hyperbola. One thing though, this right side doesn't say equal 1. So let's get there by dividing both sides by 9. So if I divide everything by 9, I got to divide each term by 9. These 9's cancel, and I get just negative x plus 1 squared plus y plus 2, quantity squared, all over 9, and this equals 1. So we're getting closer and closer to the equation of hyperbola. Remember, we want that middle term to be minus, but it's plus right now. So remember, a plus b is the same thing as b plus a, right? It's going back to algebra. So I can switch these two terms, and I get y plus 2 squared over 9 minus, because when you add a negative, same thing as subtracting, x plus 1 squared. and all this equals 1. So that's using completing the square to take it from a general form of a hyperbola to the standard form. And now from the standard form, we can do what we've done on the first 4 problems. We can go ahead and identify the center, the vertice, the hyperbola, the foci, and the asymptotes. I can't talk right now. So once you do all that, it's easy to graph. So that's what we're going to do next. So our center is going to be at opposites here, -1, comma, -2. -1, -2. Boom, there's the center. Let's write that down. We can identify our AB, and so this is like having a 1 under it. So the A term comes first here. A must equal 3. B is equal to 1. This thing is going to be vertical because the Y term's first here. And so I'm going to go ahead and make the box over here on the graph. So we're going to go up 3, put a dot, down 3, and then 1 to the right and left of the center and make our box. And then we're going to draw our asymptotes. And then from there we can, let's identify our vertices. Vertices are at -1, 1, and -1, -5. And let's not forget our asymptote equations. So the asymptote equations are going to be at y minus something. This equals the slope times x minus something. The center we said was at -1, -2, so this can become +2, and this is +1. Should be just like our equation over here, y plus 2 and x plus 1. And the slope is going to be rising 3 and running 1, and we're going to put a plus or minus in front of it for both equations. And so now we also need to know the foci, so we're going to use a squared plus b squared to find out c. A squared is 9, b squared is 1. So c equals the square root of 10. So remember, at the foci, it's going to be from the center along the transverse axis. You're going to be adding and subtracting that c value. So in this case, since it's vertical, we're going to be adding and subtracting it from the y value. So the foci is going to have the same x value, -1, as the center. But we're going to be taking that y value, -2, and adding root 10 to it. And we're going to be subtracting root 10 from it. And that's where the foci is going to be. So it's going to be just a little bit past the vertices. And now we can sketch our graph coming in like this, going towards the asymptotes and through the vertices. And that is number 5. Well, if you couldn't do number 5, you probably couldn't do number 6. So now that you've seen number 5 done, I want you to pause the video and try out number 6 using completing the square, because it's very similar to number 5. So now that you've got that done, let's go ahead and group our x's together and group our y's together. Looks like this 199 doesn't have an x or y, so it's going to be temporarily moved over. There we go. So the x's are paired, y's are paired, add 199 to both sides. And we're ready to do a little bit of factoring so we can complete the square. Factor out a 9 here. Factor out a -16. So let's say we get 9, and then x squared plus 2x. Factoring out a 16, we're going to get, we can factor out -16. You get y squared, and I believe that is 4. It is. So it's going to be -4. And then now we can complete the square over here. So half of 2 is 1. Square it, you get 1. And what I essentially did was not just add 1, I added 9, because that 9 distributes inside the parentheses there. So if I add 9 to the left side, I got to add 9 to the right side. over here. Half of negative 4 is negative 2, and negative 2 squared is 4. So I'm going to be adding 4 right there. But also remember right here, I'm not adding 4 because the negative 16 distributes to it. I'm actually subtracting 64, adding a negative 64 to the left side. So I need to subtract 64 from the right side. So I'm going to go ahead and add these up. And I get 144. And then over here, I'm going to go ahead and just factor these back. So I'm going to get x, square root of the first term. Same symbol here. Square root of the last term, 1. So it's x plus 1 squared. Go away, OneDrive. I'm going to say square root of y squared is y. Same symbol, minus. And then square root of 4 is 2. Remember, you can check these. Y minus 2 squared should give you this. X plus 1 squared should give you that. Getting closer and closer to looking like what we'd like to see a hyperbola look like. Let's not subtract, but divide both sides by 144. That will make the right side 1. And we end up with 9 times x plus 1 squared over 144 minus 16 times y minus 2 squared over 144. Of course, when we divided that by 144, we got 1. So divide each term by 144 to make that look like 1. And let's see if we can reduce this. Look at it as a fraction as 9 over 144. So let's see if that reduces. So here, both can be divided by 9. 9 divided by 9 is 1. 144 divided by 9 is 16. So you end up with x plus 1 squared over 16. And minus 16 divided by 16 is 1. And 144 divided by 16 is 9. And so here we have it. It's in standard form of a hyperbola now, and the rest should be just like numbers 1 through 4. We can identify our center. Our center is going to be at opposite values here, negative 1, 2. That's the center. And we can go ahead and plot that, negative 1, 2. Our A value is going to be the square root of 16, which is 4. The B value is the square root of 9, which is 3. Since the x term's first, this thing should look like this. We have a horizontal transverse axis. So we're going to go left and right a amount from the center. So we're going to go to the right 4. We're going to go to the left 4. Erase that stray mark right there. For the B value, we're going to go up 3 and then down 3. So here, down 3 and up 3. And now we can draw our box here. And then we can draw our asymptotes. Let's write out the equation of this asymptotes. It should be y minus something equals the slope times x minus something. Should look exactly like what we see here. The x minus something should be x plus 1. The y should be y minus 2. Remember, I'm just using the center point here and plugging those points in to get that. The slope is going to be rise 3, run 1, 2, 3, 4. All right, so our slope is rise 3, run 4, and it's going to be plus or minus right there. Now, let's see, we've got that. Let's write down our vertices. Vertices are already filled out for us. They're right here and right here. So we've got 3, 2 is 1. And the other is at negative 5, 2. The foci, we need to do our a squared plus b squared equals c squared. So we end up with 16 plus 9, which is 25. And so c is equal to 5. So the foci is going to be going 5 to the right and to the left from the center. And so if you go 5 to the right, right here, 5 to the left, you're going to be right here. So the foci are going to be at 4, 2 and negative 6, 2. Now we can draw a hyperbola. And there it is. Hopefully this is a big help to you. I want you to try out a few more problems, and I'll post those. Thanks for watching, and sorry about the audio quality. I know it's probably echoey, but I'm having issues with my mic right now, so I'm just using the computer mic. Let me know if you have any questions. Thanks for working hard and going through all this. Have a good day.